Well, welcome. Today, again, we have Dr. Miriam Salehi in biological and environmental engineering, and her graduate student, Dibya Datta. Also, they are both working on microplastics. And today we're going to talk more about the controlled release fertilizers that we all use. And I think we'll be surprised how much we really use these controlled release fertilizers. So, Dr. Salehi, why don't you start off with telling us what are they and what are some options?
So basically, the controlled release fertilizer, they have some fertilizers as the core in their granule, and then we have a coating. So we have some sort of coating around this fertilizer, so we can control how much fertilizer and how much nutrient are released over the time. So they basically provide an efficient amount of nutrient over a long period of time, compared to some conventional fertilizers that are highly soluble in the water, and they can be released into the runoff. They can have some volatilization. So they provide some efficient means of providing fertilizer for the plants.
Yeah, because we want not to have too much nitrogen, for example. It gets into our drinking water. We have nitrate pollution, and I know there's some lawsuits going on right now in agriculture and reservoirs, so there's some real issues. Also, phosphorus.
Yeah.
You know, that has contributed a lot to our dead zones in the Gulf of Mexico. So the idea of controlling this release is a great idea.
Exactly.
It really is. And we use it not only when we think of traditional agriculture, corn, soybean, alfalfa production, but in our horticulture crops. When we buy plants at the nursery, they have these slow release fertilizers that you often may see that we have right here. You see that with your plants. Those are actually feeding over a long period of time, which is great, but there's some issues.
Yes, there are some issues. Actually, we have different types. So we have a variety of these controlled release fertilizer, and they are different in the type of their coating, the thickness of this coating. So this coating could be some inorganic material like sulfur. They were very common many years ago. We still have those. And they can be some polymer coating, some plastic material coating. And then we can have some biodegradable material as the coating as well. And this coating is just protecting the core nutrient, the fertilizer present there. And then when we have the water, in the soil, we have water, so they absorb the water, they are going to soil, and then they are diffusing, releasing the nutrient gradually.
Yeah, because I know some of our micronutrients are stuck onto our major nutrients, like phosphorus, for example. When we can buy certain blends of fertilizer, they'll have the micronutrients, sulfur, boron.
Yeah,
zinc.
actually, they have different ratios. So when you purchase them, you can, what is the ratio of nitrogen to phosphorus to potassium, all of these.
But it has to be stuck together some way.
Yeah, exactly. Yeah.
And they could either be a polymer that's, like you said, made from petroleum or plastic.
Yes.
But there's other options too.
Yes. So if there are some biodegradable material like starch or cellulose or polylactic acid, these biodegradable, they are providing the coating, and over the time, then they may degrade, and they will be, biologically degrade within the soil environment. So we don't have accumulation of these petroleum-based material over the time in our soil, because the point is that after some time that they are releasing the nutrients, then we have this coating that they call that microcapsule. So they remain within the soil, and generally, as you see, the diameter is mostly less than 5 millimeters. So we can consider even the microcapsule as the microplastic that is left within the soil, because they have some of those, they have plastic coating like polyolefin, polyethylene, polyurethane, polystyrene. They are some common polymers that are used for composition of this coating.
Yeah, because I notice when I buy a horticultural plant, sometimes those coatings, those fertilizer prills are solid. Sometimes they're not.
Actually, yeah, when they add water and when they are wet, you see that, They are just flexible.
Right. So it's done its job, but now that's left over.
Yeah. And actually, there are several studies that they investigated the abundance of this microcapsule in the irrigation water or in the storm water runoff from that field. And the point is that after they are releasing the nutrient, they are there, and then we have irrigation water, we have the rain, so they can be transported to the adjacent water resources, and then they can just contaminate. In addition to the soil, they can contaminate those. And there are some studies that reported that at least 3 years after application of this fertilizer, polymer-coated fertilizer, they found the microcapsule in the soil.
Oh, boy. Yeah. So if I go, because I looked up this before we came on the air, and all your big box stores have all of these encapsulated slow-release fertilizers available. So how would I know which ones are polymer-coated or maybe natural? Does it say something on the package?
If they are green and they are biodegradable, I'm sure that definitely they should mention something. And some of those, they have some or inorganic like sulfur, but again, there are some issues with that as well, because when they have some inorganic coating like sulfur, it's uneven, sometimes it gets broken and degrade in the soil, so they may have some abrupt release of nutrient when they are using. So, always there are some pros and cons, so yeah.
Yeah, because I've noticed some of the sulfur coated, for example, they are broken up often.
Yeah.
So it does some job, but not complete. So probably if we go to buy some slow-release fertilizer, if it says biological or
biodegradable or bio-based, something.
Then we'll look for that, because not only is it our plants, I've noticed a lot of our turf fertilizers are slow release. Mm-hmm. And so a lot of homeowners are probably putting this on without even realizing it.
Yeah.
As well as in agricultural fields. So, Dibya, once these polymers get into the soil, what's the issue?
So, as Dr. Salehi was saying, like these coatings, they themselves are so small, and by definition, anything smaller than 5 millimeters is considered microplastics. So even if they don't break down, still they're microplastics. And we know when they're swelling up, releasing nutrients over time, they're getting torn apart and producing numerous pieces of microplastics. So definitely, like, it's getting spread throughout your agricultural soil when you're applying it. And then if there is a runoff, there is rain, it can get transported to the nearby watershed. So it's like we are trying to reduce the nutrient release problem. They're really efficient because they're releasing nutrient over time. So you are cutting.
Is good.
Yeah, that's really good, because like if you consider if you apply a bulk of inorganic fertilizer and there is a rain event immediately after, a huge amount of that is going to get washed away. So you'll need to apply it again, and when that huge amount is getting washed away into a nearby watershed, the problem is then nitrogen, phosphorus, those are getting into the watershed. And we know phosphorus is a huge reason for eutrophication. So water quality is degrading and bunch of stuff. So when we are applying this slow release or controlled release fertilizers, definitely we are combating those issues. Like it definitely can help reducing the eutrophication and those kind of events. So good for watershed, but again, like we are reducing the amount of nitrogen and phosphorus getting washed away into the watershed, but then we are introducing microplastics.
That's the trade-off.
So that's a trade-off. Mm-hmm. But we are solving one problem and creating a new one. Mm-hmm. So,
and do the microplastics then get into the watershed?
Yes, they definitely can. Like with the runoff, they can get washed away and they can get into the watershed.
Or they can stay in the soil.
Or they can stay in the soil as well, go downward, move downward.
But either way, they can cause some issues.
Yes.
And what are those?
So when they're staying in the soil, basically if they're blocking the pores, there will be less aeration. Mm-hmm. And aeration is really important for agricultural lands. So then the microbes which are dependent on those airflow into the soil, they are going to have less activity, We know about earthworms. Earthworms, they're called like nature's engineer, soil engineer, right? Or nature's plow, right? So there have been a few studies. They showed like earthworms showing like disrupted activities, or their reproduction is harmed by the microplastics.
Is that because of compounds released by the microplastics?
So the studies were mostly under application of microplastics directly. So I'm not sure if they're referring to directly the compounds released by the microplastics or microplastic itself, but
just the whole structure in there.
Whole structure in there. So those microplastic particles are causing some harm. So it may be the chemicals released from those particles or the particles itself.
Yeah, because we talked about once before that they have a charge on them, don't they?
Yeah, they can have the negative charge.
Just like soil.
Just like soil, like the clay.
So they can have minerals attached to them that maybe can't be pulled back off by the plant.
It is possible.
Yes.
And those studies, there are a few other studies, they are saying like in the rhizosphere region, they are saying like after application of microplastics, the microbes activity, the beneficial microbes activity sometimes reduces and like pathogenic activity increases. So that creates more stress on plants.
Sure.
So that's a problem. Like we are providing more nutrients for the plants, but again, creating problems with the microplastics.
So are there any chemicals that we should be worried about that get released from the microplastics?
From the studies in our lab, we know they can release organics as they age, like due to photodegradation. So as they're exposed to sunlight, they can release some organics. But we studied that in the form of dissolved organics. So specifically, which organics are mostly releasing from the surface of the microplastics, we haven't gone that far yet. So, but
there are some studies that they look at the additive release or organic leaching, what type of organics are leached. But regarding the control release fertilizer, they left in the soil, and some people are working on the soil. We have heavy agricultural machinery passing on the soil. So that may result in their further fragmentation to the smaller particles. And these smaller particles, they can penetrate in the soil column as well.
And go throughout the whole soil column. Yeah. And we're finding them then winding up in plants.
Yes, they can wind up in plants. And if you are applying herbicides or pesticides in the field, those can also get picked up, like absorbed by the microplastic surface. So if they somehow go downward and eventually reach groundwater, then groundwater resource can also be contaminated. And again, if you think from the perspective of our drinking water supply, like water treatment plants, they haven't developed any efficient microplastic removal method yet. So more microplastics, when it get into the water, like water treatment plant, if they're sourcing from groundwater, for example, like in the US, still 38% people are dependent on groundwater, like 38% of the total drinking water is sourced from groundwater. So if microplastics is getting in there, that one source we know is harmless and we can drink without any further like thinking. But now we have to think about that as well.
Yeah. So, well, at my house, for our drinking water, all water, we have a softener, but then we have another filter for our drinking water. Would that get it out?
So depends on the filter pore size, what kind of filter you are using.
So we may not be using a fine enough filter to get these microplastics or even nanoplastics, even smaller.
And like if you're using a finer filter, if you're like what kind of water force it can withstand, depending on that, how often it will clog, like the smaller the particles, the more the chance it will clog.
Because we have found it in our bottled drinking water. So we know that it's getting to our reservoirs or to our groundwater some way.
Yes.
And that's going to be a real issue. I was looking up my favorite fertilizers and noticed that they were on the list. But you said that's not, it could be.
Yeah, some of the control release fertilizer, they don't have the polymer coating. Some of them, they have sulfur or some minerals. Some of them are bio-based. So it's different. Not all of the control release fertilizer have plastic in them. So it's different.
So we need to look to see what that is.
Yeah.
Okay. So that's something that we should be looking for. What is this made from? and if it's bio-based, then we're okay. Because you said like cellulose and
Starch, polylactic acid.
Polylactic acid.
and those can be broken down by the soil microbes over time.
Yeah.
Will the soil microbes break the microplastics down over time, or they just kind of keep getting smaller and smaller and smaller and smaller?
So basically, there are some enzymatic degradation, but eventually the main goal is that they be converted to the biomass, carbon dioxide, and water eventually. Yeah.
Eventually, yes. Yeah. And of course, when they are being decomposed, there can be some release of chemicals that we haven't even scratched the surface on yet.
Something that I want to add is that sometimes this slow release fertilizer, generally they are more expensive than conventional fertilizer. And if you want to look for the biodegradable coating, that would be more expensive. So somehow, I guess the decision maker, they can support the farmers, but providing some sort of incentives to support them, going toward, this bio-based, biodegradable, coated, slow release fertilizer or control release fertilizer, because they are going to provide the advantage of the nutrient release efficiency, and then also we don't contaminate the environment. So there should be some sort of program. We should inform the farmers, and also there should be some program to support moving toward this.
Well, and consumer demand is one of the best ways to do that. We talked about that earlier when we use in our horticultural crops plastic mulches, that if those are made from petroleum or if they're made from a cornstarch or something that will actually biodegradable. So again, we're in that same situation where consumer demand can help this.
And something else is that these microcapsules, after they are releasing the nutrient, they stay within the farm, and then they can be transported by the rainwater. Something that farmers can do is that at least they do some sort of management for their stormwater, so they prevent releasing of this through their stormwater to the adjacent water resources. Some sort of green infrastructure, something that they can manage it.
That's a great point, that just keep the stormwater from leaving the farm.
Yeah.
Yes. I know in Iowa, they're really talking a lot about that because they have some real issues. So much nitrogen fertilizer that's put on and trying to, not so much of it to be lost. Yeah. And it makes sense because it's more economical for the farmer, for the producer, and also helps the consumer. Mm-hmm. All right. Well, this has been great, I think, because this is really touches everybody that grows plants, purchases plants, or has a garden, or has a yard that you fertilize, because we all like that slow release that we don't, even in our yards, that we don't get all of it at once, that we don't wash it off. It's over a period of time. We just want to make sure we're using the right product.
I just want to acknowledge our funding agency, USDA, NRCS in Missouri, that supported us in this project to inform the farmers and public regarding the plastic pollution in agriculture.
Exactly, because it shows that they are concerned about this, and they want to have clean water and healthy environment for everyone.
Yeah.
All right. Well, this is it for this session, and we'll see you next time.